Hi, this is Matt Davis with Brown & Caldwell. I'm going to give an overview of how to use CAPE to generate flows and load those flows to nodes. So CAPE has a few different components it uses in this process. It uses loading behaviors, drainage behaviors, and wastewater models. The loading behaviors are responsible for generating the flows and loading them at a particular location in the system. Those locations could include parcels, nodes, or other geographic areas. Drainage behaviors are responsible for taking flows at a particular location and transferring them to another location. Usually these drainage behaviors have some kind of rule-based behavior that can assist in moving the flows from one place to another. There are lots of different types of loading behaviors and drainage behaviors in CAPE, which makes it very flexible, provides a lot of different ways to generate the flows and to move the flows around later. Now, the wastewater model is responsible for generating the flows, assigning them to the proper location, using the loading behaviors and the drainage behaviors. And it does this through flow groups. And flow groups are basically different sets of flows that you want to model. And you can set up different ones. You can have multiple different types of flow groups within a wastewater model. For example, you could have base infiltration, you can have another one for RDII, you can have another one for base sanitary flow. Each flow group defines which loading behavior is used and any drainage behaviors that are needed to move those flows to the proper final destination. And I'll just show you what that looks like in CAPE real quick. I've got a work group open, and let me close this out so I can reopen it. So here's a work group I've already got, and I'm just going to jump right to show you the different pieces. We've got the drainage behaviors here. I've created 4 different kinds. Loading behaviors, I've got 3 different kinds here. If you want to create new ones, you just right mouse click on drainage behaviors and you go to create. These are all the different kinds of drainage behaviors that you can create. Same thing for loading behaviors, to create different ones here. And then our wastewater models, we've got one wastewater model, of course. As you probably figured out by now, you can create new ones by right mouse clicking. I'm gonna open up this wastewater model so you can see what the flow groups look like and how they combine the different flows together. I've got 2 different flow groups in this wastewater model. I've got one called base sanitary flow. I've got another one called RDII. This little checkbox at the top says whether or not to use this flow group when the model's run. So right now, base sanitary flow is turned off, and if I run this model by clicking down here, it's only going to use the RDII. Each flow group requires you to specify a loading behavior. I'm just going to look at base sanitary flow here for a minute. It's using the one called simple flows, and then down below here, I can specify which drainage behaviors I want to use, if any, to take the flows loaded at the nodes from the simple flows loading behavior and distribute those to different nodes. And I'm using a number of different drainage behaviors, as you'll see here. I've got 2. Actually, I can scroll down here. I've got 3 different drainage behaviors that I'm using. And so that's what the wastewater model looks like and how the different drainage behaviors and loading behaviors are combined together in the flow group to simulate flows. So let's take a look at a particular example, and I'm going to continue to work with the around the CAPE work group that we were just looking at a minute ago. So let's talk about the base sanitary flow that we were just looking at in that flow group. And here's our situation. We've got sanitary flows that we've estimated at flow metering locations in the sewer system. And what we want to do is we want to allocate the sanitary flows to nodes in the upstream portion of the sewer system based on water usage so that the flows can eventually be routed through a hydraulic model. Here's the available data that we've got to perform this analysis. We have the sanitary flows we've estimated, and we have the IDs of the nodes where those flows were estimated. We also have parcels with water usage, and we have a GIS layer, or layers, of the sewer pipes and the nodes for the full system. So this is branching all the way up, all the way to the system to include all the pipes and nodes. And for convenience, I'll call this the extended network. Now, typically when you model a system, you don't model everything. So you model just a subset of the extended network. So we've got, in this case, we've got a model network, which is just a subset of the extended network. And CAPE will build this, this model network dynamically from the extended network if it knows the extents of the model network. And so all you have to do to specify the extents is provide the IDs of the pipes in the extended network that are immediately upstream of the terminal pipes in the model network. So with that information, CAPE will pull up the extended network. It'll see, it'll look for those pipes that you've just specified, and it'll go one pipe downstream and start tracing, and trace all the way downstream, and that will define the model network. This can be kind of convenient, because if you have updates to your extended network, which can happen often in modeling, you only have to update one network within CAPE. You don't have to go and update two networks, because they're basically the same network. One is just a subset of the other. Let me show you what this data looks like in CAPE. Let me show you the parcels. The parcels are under geographic areas, and here we've got Picasso parcels. These were imported from a shapefile. We've got the ID, name, land area, whether or not they're sewered, and water usage. We've imported all that data. There's some other data that we didn't import, but we're not going to be using it for this demonstration. And then we've got our networks down here under network data. We've got the Picasso all pipes network. And this network is based on two shapefiles, one for nodes and one for the pipes. And you can see CAPE is defining some information attributes by picking out fields from those shapefiles. I can't change any of this information right now. I'd have to hit the edit button first. But I can go in and see a table of the pipes and the nodes. And by the way, if there are any problems with the network connectivity, you'll see little flags popping up in this data. But everything looks nice and clean. So those are the pieces of information that I wanted to show you that we have going into this, the development of our base sanitary flows. So basically, here's the basic idea. We want to assign the flows at the locations where the flows were measured. Then we want to distribute those flows to upstream parcels based on water usage in the upstream area. Then we want to assign the flows in those parcels back to the extended network. And then we want to assign the flows from the extended network to the model network. So we do the first step, which is assigning the flows to the nodes where the meters were located, using a loading behavior called it's a generic nodes loading behavior. Then we move the flows to the parcels using a nodes to upstream parcels based on parcel attributes drainage behavior. And then we move the flows from the parcels to the extended network by using a parcel to nodes drainage behavior. And then we move the flows from the extended network to the model network using a network nodes to subnetwork nodes drainage behavior. And all this is kind of summarized down at the bottom here. We've got flow at the metering nodes, we go to parcels, the extended network nodes, and then to the model network nodes. You may be wondering why we don't go directly from the parcels to the model network nodes. The reason why is it's typically easier to go to the extended network first, because the extended network extends all the way up through the system. So it's a little easier to tie the parcels to the nodes when you have a network that extends all the way up. That way you don't have to do the connection of the parcels to the network and then tracing downstream in one step. You can break it into two different pieces. So that's why it's a little bit easier to do it that way. So let me just show you these pieces. We looked at the flow group a minute ago for the base sanitary flow. We've got a loading behavior called simple flows, and then we've got three different drainage behaviors. So let's go look at the simple flows loading behavior. That is right here. So I'm going to view it. Simple flows is very simple. First of all, you specify what network you want to assign has the nodes that you're assigning flows to, and this is the one called Picasso all pipes. This is the extended network. And then we've got a table here. We've got basically the flow and the node where that flow is assigned to. And I know that we're talking about sanitary flows, but just for simplicity here, I'm using a constant flow at this location. I could easily go and change this though to a cyclic variation, which would better mimic a base sanitary flow. But for now, I'm just going to keep it simple. So I've just got three different loads that I'm assigning in this simple case. So after the flows are assigned to those nodes, then we use these drainage behaviors. We've got one here called wet well flows to upstream parcels. Wet well flows to upstream parcels. Okay, so I'm going to go and view that. Now, this is a transfer flows from nodes to upstream parcels based on parcel attributes drainage behavior. And we talked about that just a minute ago. And it needs to know what network to transfer flows from. So it needs to know what kind of network it should be using, and it's going to use the Picasso all pipes, which is the extended network. It needs to know which parcels to use, the Picasso parcels. It needs to know how the nodes and parcels are tied together. And there's a type of drainage behavior called a parcel to nodes drainage behavior that specifies those connections. And so I've specified that here. And then we need to specify what attribute of the parcels we want to use to do the distribution. And we're using water usage in this case. So let's go back to see what our next drainage behavior is. So once we've got the flows in the parcels, we want to get the flows from the parcels to the Picasso all pipes network. We're using the parcel to nodes drainage behavior for that. I'm going to view that. So first we specify what network we're transferring the parcels from, and that's the Picasso parcels, and then we specify the network that we're transferring the flows to, and that's the Picasso all pipes. And then here's the connection of the parcels with all of the nodes. And then we've got our last drainage behavior, all pipe nodes to LHM nodes, and that is over here. And this basically is one that will transfer the flows from the extended network, which is the Picasso all pipes, to the model network, which is the Picasso LHM. Now, if the flow is at a node that's common between these two, in other words, where their extents overlap, then there's really no translation. It just goes from the node, node in one network to the other network, but there's no translation involved. However, if the flows are located in the extended network further upstream from the model network, then what CAPE will do is it'll trace those flows down until it reaches the first node in the model network, and then it'll assign the flow at that location. So we're done we've gone through all the different pieces of this wastewater model, or this flow group within the wastewater model. So let me show you. Let's talk about RDII for a second. To provide another example of how flows can be generated and distributed within CAPE. So let's, for this example, let's assume our situation is that we have RDII hydrographs that have been generated at flow meter locations in a sewer system, and we want to allocate the RDII to upstream nodes based on inch diameter miles in the upstream system. Now, the data that we've got to do this are RDI hydrographs and the corresponding IDs of the flow metering locations. We've also got the GIS layer of the extended network, and then we've got the IDs of the pipes used to build the model network from the extended network. So here's the steps to perform this analysis. We first assign the flows from the hydrographs to the appropriate nodes, and we do that using a generic nodes loading behavior, but there's other ways we could do it too. There are loading behaviors set up that can directly take flows from I&I models and assign them to nodes. But once that's done, we want to distribute those flows to the upstream pipes in the extended network based on inch diameter miles, and we use a drainage behavior called nodes to upstream nodes based on IDM drainage behavior to do that. And then the final step is to take the flows at the nodes in the extended network and transfer them to the model network nodes. And again, to do that, we're going to use the network nodes to subnetwork nodes drainage behavior. And going back to CAPE, let's look at the second work group, second flow group down here. It's called RDII. Again, we're using the simple flows loading behavior. I know and I was just talking about using hydrographs, but the simple flows is just using constant flows, but it would be just as easy to reassign those flows to hydrographs instead. But for simplicity, we'll just stick with the constant flows for this example. And then we're going to use two drainage behaviors. We're going to use the one that transfers flows to the upstream pipes, and it's called wet well flows to upstream pipes. Let's go take a look at it. And this one's very simple in terms of setting up. All you have to do is specify the threshold that's used to indicate when a new target node should be specified. So the way this works is CAPE will start at the node where the flows are being loaded, and it's going to start walking upstream and keep a running total of the inch diameter miles as it goes upstream. Every time that running total exceeds this threshold value, and right now it's just set to 2 inch diameter miles, it's going to create a new target node. And it's going to reset its counter and start walking up again to find where the next location is. Now, when it gets to an upstream node in the network, in other words, a terminal node, it's going to go ahead and assign any leftover inch diameter miles allocation that it has in its running total to that location. So you're always going to have an upstream flows loaded at the upstream nodes, even if this threshold value isn't met at that location. Also, as CAPE works its way upstream, if there are other nodes upstream that have flows, it's not going to go past those nodes. It's going to stop, because it's what it's going to assume is that there's another meter at that location, and it's going to say, okay, that meter is going to assign its flows upstreams. So I'm not going to walk any further up into that part of the system. Otherwise, I'll be loading flows incorrectly. So that's it for. I think I've covered all the different parts in CAPE for these two examples. In summary, CAPE just gives a lot of flexibility for loading flows and being able to distribute those using the loading behaviors and drainage behaviors.